Good morning. This is your very first lesson in geometry for semester one of 2021. And this is geometry lesson 1.1, and it's on points, lines, and planes. You've heard of points, lines, and planes before. I'm going to take some time to kind of walk you through what they really represent and how you describe them. And then we're going to move on to other deeper things. This lesson also supports and a couple of IXL skills. One is on properties of line segments and rays, and the other one, B2, first one was B1, supports properties of planes, lines, and points. So we're going to be looking at all those things in our discussion today. This is a video, and because it's a video, which you have just seen was a download from YouTube, even though this is me talking, of course. But it's also set up as an outline. So for those of you who need an outline, you can feel free to copy this. You can take pictures of it. I have no problems with you doing that. And then, of course, I do want you, when you do these notes, I want you to take careful note of definitions. Make sure you write them out. I provide you with the definitions in many cases, in which case you just need to highlight them. But in your notes, I want to make sure that you write them out, because in geometry, definitions are critical. Everything that we do in geometry is based upon physical observation. And because of that, you have to be able to name and describe everything. Think of a little kid just learning to understand what a shoe is, or what a carrot is. You have to describe it. So that's what we're going to be doing as we go. All right. You're going to take notes on this lesson. And so you can, like I say, you can copy this down. You can take a picture of it if it'll help you out. You also must go through this and listen to what I have to say, because besides what's in the outline, there will be times when I write things out like I did up here or down here. And usually I'll be sketching and drawing as I go. So I want you to add those things. And make sure that, again, the definitions are learned and that you memorize them. It's the same with formulas. It's the same with rules. You will be doing this all the way through geometry. So prepare yourself for that. If you know it now and you do it from the beginning, you'll be fine. Now, every time you take notes, and most days I will be giving you a video lesson, not all days, but most days, then you're going to upload them to me. So you can upload them to me through Student View, and I'm going to give you until 11:59 p.m. of the Wednesday that follows this week. Okay? So in this case, we're starting on a Thursday, and so I'm talking about that following Wednesday of the next week is when you have to upload this to me if you want to have full credit. Okay? All right. I'm going to dispense with this at this point because I'm going to revisit it here in the next page. Okay. So I did write some things here. So we're going to start out with certain undefined terms and definitions. So you know what a definition is, but it's up here. I made sure that it was included. So a definition uses known words to describe a new word. That's all it is. Okay? And in geometry, however, some words such as point, line, and plane are what we call undefined terms, meaning we don't come up with much of a description for these, okay? Because they're just so obvious that you can understand it. That's the thinking. Again, everything in geometry is based on observation. So, if you're basing everything on observation, you start with some very generic things that everybody understands, and that's what undefined terms tend to be. Okay, so let's make sure we've got general agreement on what these are. So a point has no dimension. It is usually represented by small dots. So here it is, small dot. It's represented, and it's just a location. So all it is, it's a location. So if you think of it as a location, the only thing that you can do to describe a location in space and time is by coordinates. So if you're on an XY coordinate chart in geometry, X and Y are the coordinates. So it might be X is 3, Y is -6, something like that, okay? So it's a location. You cannot see in real life a point, but this is our attempt to describe it on a piece of paper. And then down here, if we want to talk about what the name of it is, which point is it? Oh, it's point A. How do we know? It's because there's an A next to it, but down here we write it out as point A. All right, now you got a line. So a line extends in one dimension. It is usually represented by a straight line with two arrowheads to indicate that the line extends without end in two directions. So, we're going to always use a straight line. Now, I took this from our old geometry textbook, so you'll see it referring to books. And a lot of this stuff you can see is pure textbook. That's all it is. But here's a line. Okay, this is a drawing of a line. And it's got a description up here. There's a curlicue L, so that means that this is the line L. But it also has a couple of points on it. All right? And so this is the picture of it. It's not the actual thing, because remember, a line is just a series of points all strung together, okay? So if I were to draw a line, I start out with a point, and then I put another point next to it, another point, another point, another point. And remember, because points have no location, they just get kind of jammed together, and pretty soon you see you got a line going in two directions, okay? So we create notation, and down here when I showed you what point A is described as, that's notation describing point A. Well, this is notation describing this line L. You can say line L, or what they set up here, you could put in a B down here, and then above it you'll put a little line and then two arrows, one on each side, because that shows you that the line is going forever and ever in two directions. Now, the last thing is a plane, and a plane extends in two dimensions. So going back to the line is just one dimension. So this is one dimension. And there it is, the line. And so, you can't really see a line because it's just a string of points which are just locations in real life. But you can represent it here just the way we did. And this is one dimension length. Now, plane has two dimensions. So dimension 1 that's this one, length. Dimension 2 is width. Okay? So you can see length and width so long as it's facing you in some way. Now this representation of it kind of, if you think of it off the page, it's kind of come off the page at an angle, and that's just to kind of give you the feeling that you're seeing it in three dimensions, but you can't. Better way of seeing it, this rectangle here that's in gray has little lines around it, and so you can see you got length and width, and you can see this, okay? But if I were to turn it on its edge, like this piece of paper, if I were to turn it on its edge, let's see if I can do this. Kind of hard to do. Almost. You can see that you're coming up with a line, and so then the line kind of disappears. Okay. Now this camera doesn't have the optics to do what I would really like it to do, which is to show the line to disappear. I'm going to try to find a recording of just exactly that illusion so that you can see it. as it really is. Okay, so this is a simple definition of what we call collinear points. So related, a couple other related undefined terms are collinear points. That's points that lie on the same line, and coplanar points, and those are points that lie on the same plane. So we're going to take a look at that. So here we have an example of some collinear lines, collinear points and coplanar points. So collinear points are points that lie on the same line. So if you look at this line here, it has 3 points on the line, D, E, and F. So that would be your answer here for this particular question, for the question A. These 3 points are what we call collinear. Now they want 4 points that are coplanar. So here's the plane, it's the blue, right? And so on the blue plane is G, D, E, and F. H is not on there, it's above it. So it's not included. So these are the 4 points. So let's see, D, E, F, G. So D, E, F, and G, those are all coplanar. Now, name 3 points that are not collinear. Well, let's see. Does D here share a line with H? No. So D and H are not collinear. Does G share a line with either D or H? No. So D, G, and H are 3 points that are not collinear. Okay. So you could find other combinations in this, and I'll let you figure out the answer. So I'll take a moment and just look and see, what can you show 3 points that are not collinear? Do you have some more choices here? Try to do that. See what you can come up with. There are many correct answers. Okay? They just give another set for you here. Okay? All right. Let's move on. Now, what happens when 2 or more points are described on a line? So here what we're doing is we're going to be looking at how you describe them such that somebody else, when you tell them or give them the description of whatever point or line segment you're looking at, that they'll understand which one you're talking about. So it's like the old joke, got 2 people are walking through the creepy woods, and one of them hollers, "Werewolf!" And the other person says, "Oh, werewolf." Okay? As if this were a wolf right here. Okay? So, it's a joke, but nevertheless, you get the point. So, here, consider line AB. So this is line AB. And the line segment, or segment AB, that's this one down here. And they give you the symbology for it, the notation for it. And notice that AB consists of the endpoints A and B. And all points on line AB that are between A and B. So these points right through here are the same as these points right through here. Okay? All right. Now, here we're looking at something called a ray. And a ray, you'll notice, has an endpoint. In this case, it's B. And then a line that extends to the left forever and ever. Amen. Okay? So that means that this ray has a starting point. Okay, just like this and an end point. And up here, the line segment, I should have said, has two endpoints. So AB has a beginning and an end here. Down here, ray AB, as opposed to segment AB, ray AB has a beginning, but it does not have an end, because this arrow shows you that it goes forever and ever and ever to the left. Okay? And don't confuse and say, oh, well, this is really ray BA. Because when you're describing a ray, you always use the endpoint as the beginning of your letters. So BA is the correct description for this ray. Okay? So in contrast to that, AB is the same as, line AB is the same as line BA. Now, why is that? Well, it's because if you go up here and you look at the line, you'll note that they go in both directions. There is no endpoint. So you could switch those around easily, but not with a ray because it has an endpoint. Okay? Also, line segment AB, I could switch those around because the endpoints are exactly they're the same in makeup. Okay, so we can call this either line A or line AB or line BA, and we'd be correct. We could call this segment line segment AB or line segment BA and be correct. But this ray we have to call ray BA. Now, here you've got a line that has 3 points on it, C being the middle point. So what they're saying there is, okay, what you have is opposite rays. One goes this way, one goes this way, okay? And so C is the endpoint for both of those rays. And because it's the endpoint for both of those rays, then it will be the first letter when you describe the left side, left ray or the right ray. So CA, that's this left-sided ray. It starts with C. CB, notice that the arrow goes now to the right, where it here, and it also goes to the right here. But now CB is talking about this over here. So don't be confused by this. You see that the arrow is going in the same direction up here in the notation. But the letters are switched. And the letters are switched because they're trying to tell you that CA here is really referring to this portion of the ray that's on the left side of this line, going from C to A and off into infinity. And then over here, this is ray CB, okay? And again, it starts with at the endpoint C, and then it passes through B and goes off into infinity, okay? So, and then again, like points, segments and rays are collinear if they lie on the same line, okay? And they are coplanar if they lie on the same plane. So be sure you remember that. Collinear if they lie on the same line. They are coplanar if they lie on the same plane. All of these things will do that, okay? All right. Now, let's go from 0 to 1 dimension, okay? So what we're going to do is we're going to draw 3 non-collinear points. And let me just grab something over here. Okay, so I'm going to draw 3 points. I'm going to call this J, I'm going to call this K, we're going to call this L. All right? So we just did that. Drew 3 non-collinear points. Now, why are they non-collinear? Well, they wouldn't share the same line, would they? I mean, two of them could. I could draw one through JK or KL or through JL, right? But now they want me to draw a line JK. So what I'm going to do, let me see if I have my protractor. Yes, I do. And let me get a pencil. Here, I have one. So they want me to draw a line JK. Well, here's J and here's K. So what I'm going to do is I'm going to draw a line that goes through these. And there is, by the way, a rule that says it's called a postulate, and which means it's a definition that is so simple it doesn't need to be explained. But between 2 points, there always exists only one line. Okay. So they said draw JK, then draw KL. KL, well, KL goes right here, but look at this. This doesn't have any arrows on it. So they want a line segment. So I'm going to do this in red. I'm going to do a line segment from K to L. Okay, I'm a little inexact, but that's basically what I did. And then they want to do ray LH. So that, I'm sorry, LJ. So that's a ray that starts at the end. What's its end point? It's got to be L. Okay, so you have to follow the rules that we did before. So we've got to start here at L, and I'll use, oops, where did I put my pen? There it is. I'm going to start at L, and I'm going to draw a ray. So remember, it starts at the end point L, and it's going to go through J. So that has to go this way, and remember, it's going to go on forever and ever, amen. So now, what I've got is the three drawings all superimposed on top of each other. Notice what it did is in the middle of it you form a triangle, and we'll get to that kind of stuff later. But you need to be able to follow these directions exactly. So when you do any geometry, will you please read carefully and draw, and then double check your drawing to make sure, did I get it right? Let me see. JK is the line. I've got to have arrows on both ends going extending out from J and K. Yep, that's correct. KL, that's just a line segment. So I draw a line segment between K and L. Got that, that's correct. LJ, that's a ray, starts at L. Yep, goes this way, all the way through J and out. I did it right. Okay, so this is correct. So that's all we want to do with that. Okay, pretty simple. All right, now, drawing and describing opposite rays. So what we're going to do is we're going to draw two lines, that's what they want us to do, and label points on the lines and name two pairs of opposite rays. So draw two lines. Now they aren't specific about whether the lines are perpendicular to each other. And what does perpendicular mean? Perpendicular means that the two lines are at a 90-degree angle to each other. So for instance, I got this protractor line going this way, and if I were to draw a line that cuts through the 3 here, you'll notice that there's a line there that's perpendicular to this edge. So I could draw a perpendicular line, but I'm not going to do that. I could, and it would have been fine, but instead I'm just going to draw two lines. I'm not really worried about where I draw them because it doesn't matter. They haven't asked me to do it any other way. So I got my two lines. Now, they're lines, so I got to put, not line segments, so I got to put an arrow on the ends of these. If I don't put the arrow on, they're just line segments. Okay? Now, they want you to label the points. And it doesn't tell us, but let's see. Why don't we put a point here and we'll call it M. And we'll put a point down here and we'll call it N. So that's line MN. And then I'm going to put a point down here, I'm going to call it P, and I'm going to put a point up here, and I'm going to call it Q. So that's line PQ. Okay. All right. So 2 lines, label points on the line. So I just label points on the lines and name 2 pairs of opposite rays. So they want opposite rays. Well, I need a middle point, so I'm going to put a middle point here, which I'm going to call X. All right. So they want 2 pairs of opposite rays. Now remember, one pair is 2 things. So it's like a pair of socks. You don't put on just 1 sock, you put on 2 socks. So I've got this line PQ, it has a point here in the middle, and so there's a ray that goes off in this direction from the endpoint X, okay? All right? And then I got another ray that goes in the opposite direction. I'm just going to highlight it. And it goes from X to Q and out, right? So what would we call this? We'd call this XP. So this would be ray XP. So the first pair, I've got the little ray sign, and I'm going to put XP. And then the other one, I start again at the end point, and I go to Q. So I got ray XQ. Okay? Let me move this up so you can see it. Sorry about that. All right, and then over here, I've got this other line, MN, and X is the midpoint. So we're going to draw a ray over this way, and so that's got to be ray XM. Okay, and then we've got one more ray on that line, and I'll use this. Whoops, got messy there, sorry about that. And so that's ray XN. So ray XN. So we've got 2 pairs. And so those are the opposite rays. Okay? Pretty simple. All right. So I'm going to move on. This goes pretty fast, as you can see. All right, so now we're going to progress from 1 to 3 dimensions. Now, why do I say two dimensions? 1 to 2 dimensions? I'm sorry, from 0 to 1. Up here, 0 to 1, remember we were going from, this was 0 to 1 because we were going from points to lines, and so we went from no dimension to length. Now, since these are intersecting, you could argue that they lie on a plane and that that's 2-dimensional. But here we're going to actually look at the intersection of lines and planes in this one, so we can talk about the length and width. So 2 or more geometric figures intersect if they have 1 or more points in common, okay? And the intersection of the figures is the set of points the figures have in common. All right? So we're going to sketch the following figure. So first of all, it's a line that intersects a plane in 1 point. Let me just see if I can get rid of this. Okay, so I'm going to have to do this in hunk number 2. I'm going to start.